we start a short 3-day practical course of SPM12. SPM is a piece of software dedicated for the analysis of neuroimaging data. It is developed in London more than 10 years ago, and 12 stands for the year when the most recent version of the software was updated. And we will try step by step move through the process of the very basic tutorial of a special preprocessing and first level statistical analysis of a sample neuroimaging experiment. In particular, we will work on reorientation, realignment, coregistration, segmentation, normalisation, smoothing. This is the first part, which is the pre-processing, and then we will try a little bit of statistical analysis, which is model specification, review of the model, estimation of the model, and statistical inference. At the moment, all those words can look strange and unclear for you, but I hope that at the end everything will be absolutely clear and useful, and you will be able to navigate easily through different steps of the analysis of the fMRI data. If you have any questions, don't hesitate to interrupt me immediately, and I will try to answer them as clear as I can. First of all, what you had to do before this course is to install MATLAB on your computer and to download and install SPM12. SPM12 is freely available by this link, and hopefully it is already installed in your computer.
I think we can see your screen. We see your webcam.
Okay, let's see if we can manage this. The web camera is not what we need. We need the screen. Now, can you see my screen?
Yes.
Perfect.
Can we ask you to speak a bit louder, please?
No problem. If you didn't install SPM12 correctly, but you have it downloaded already, it is not a problem, since I'm going to show you how exactly can we install SPM12 and make it work in MATLAB. It is very simple. This is my disk C, and there are two important folders. Data fMRI, this is where I store all the data, and we will get back to this folder later. And folder SPM12. This is where all the files and folders of SPM12 are unpacked. Hopefully you have the same on your computer. But this is not enough to make it work. You have to start the MATLAB and to go to File, Menu, and pick the Set Path option. Here you have a list of all the folders which are added to MATLAB path. That means that MATLAB will automatically, at the start, acquire all the files from those folders. You just have to add one folder, which is SPM12. You go to disk C, you find SPM12, you pick it, and you click OK. Now it is in MATLAB path. Then you press Save, and then you press Close. And now you type in the command window of MATLAB SPM. That's it. Very simple. And click Enter. Normally you should see something like this. This is the first window. There are many options of how you can use SPM for analysis of PET, VBM, EEG. We are interested in fMRI, so click fMRI. As you can see in the background, SPM starts. OK. And you have 3 windows of SPM opened. This is the menu window, very important with all the necessary buttons for the preprocessing and statistical analysis. The interactive window, sometimes very important and useful for, in particular, for the manipulations with the statistical results. And the main graphical window, which will be used all the time. There will be more windows, but later. At the moment, those 3 are sufficient. Let's go back to our presentation. And pretend that everything is installed. A brief introduction to the web page of SPM is always useful, because in this web page, except the software, in addition to software, you have a lot of extremely useful links, which are the courses, the email list, and the data. Courses, mail list, datasets. If you want to be able to understand well how the neuroimaging analysis is performed in SPM, how to use it, and how to improve your qualification as a neuroimager, you should definitely see the courses. They have plenty of tutorials and videos, and this is the team of the developers of SPM. So this can be considered as a gold standard of education in this field. Email list. If you didn't subscribe to mailing list of SPM, do it. You will get a lot of information on courses, issues with software functioning, job openings. You will see directly how all the issues and questions of the trainees are rapidly addressed and resolved by the active members of the SPM community, including the developers of the software. And of course the data, free, always available for your training and testing different ideas that you might have concerning the data analysis. You can download it and try to work with it. This is very useful. This is the logic of how to add SPM12 to MATLAB path. This is what we have done already. File, set path, SPM12. Save and close. And this is another important thing you had to do in advance. The download of Auditory fMRI dataset. Hopefully you did it. It is available on the same site, and you see the link. Then you had to unzip, unpack the data to the folder as indicated here. Actually, this name can be arbitrary. It is just to be consistent, so that we all have the same names of the working directories. After unpacking, you will see that there are two subdirectories, F and S1. F stands for functional, S stands for structural. And in addition to this, you create your own directories, functional and structural, and copy all the files from respective folders to the new ones. It's better to do it so that you always keep your original unprocessed data, and you always can go back and compare your folder, your files with the original files if something is different, if something has been changed. What is the auditory data we are going to work with? This is one of the first experiments, fMRI experiments ever. They have never published the results of this experiment, and it has been always used for education, training, testing systems. So let's appreciate what is available, and let's go into details of the experimental design. In total, there were 96 acquisitions, 96 scans. Each scan took as long as 7 seconds, which is extremely long. Now typically functional scans take just 2 seconds. This was long ago. It was a block design, which means that every 6 scans were acquired during the same condition, either stimulation or the rest. That gives you 16 blocks. Each block lasts 42 seconds. The blocks alternated between the rest and auditory stimulation, starting with rest. This was the first block. Silence. If you can call silence what happens in the scanner. Actually, the scanner itself, the MRI scanner, is very noisy. So the rest is just the scanner noise, and this auditory stimulation is the scanner noise plus something else, which is listening to bisyllabic words presented every second, like mother, house, weather, movie, and so on and so forth. So it's a complex stimulation, auditory, meaningful, semantically rich. The data files start from acquisition number 4, and you will see that the first file is called like this: fm00223 004 underscore 004. The first few scans, in fact not few, but the whole first 2 blocks have to be discarded as dummies. We will get to this later. This is how you can make a plot in MATLAB to see in a graphical way the sequence of those blocks timed over seconds. First 6 scans rest, second 6 scans stimulation, then rest again, then stimulation again. Each of those takes 42 seconds, which is 6 times 7 seconds. This is the MATLAB code. You can simply copy and paste to your command window in MATLAB. First you have to create the figure. And this will give you exactly the same plot. I introduce you this piece of code so that you imagine approximately how MATLAB works in general. Today we will not discuss the syntaxes of MATLAB and how useful the MATLAB functions are, but I strongly recommend you to keep it in mind. This is a good thing to know MATLAB programming, whatever you are going to work with in the future. Doesn't matter if it is neuroimaging, electrophysiology, behavior, animals, humans. Anyway, MATLAB is going to be very useful for you. As it was useful for me. If you remember, we have to prepare the data. I go to my disk C, open data fMRI. Here is the folder for mother of all experiments, as they call it. In this folder we have just one zip file. This is what you normally download from their web page. You extract it. Okay. The troubleshooting. I will have to restore the folders that I have deleted this morning. Hopefully it's going to work. I can just take just those two. Okay. I think I have moved all the files from this zip folder. And now we have F and S folder. Here we have a single file, which is a structural one. And if you open it, you can see that it is structural. The quality is good, you can clearly see the anatomy. And the other folder gives you a long list of functional acquisitions, starting from 4. The next step is to remove the dummy scans. Since at the very beginning of the functional MRI acquisition, there is a so-called T1 effect, which means that first scans are systematically different from the rest of the acquisition. In order to avoid this artifact, you select first 12 scans from 04 to 15 and you move it to a separate folder, which we can call dummy. And I'm going to do it right now. "24 files" means 12 acquisition. Each file has two parts, the header and the data file, EMG. This is one of the formats supported by SPM. Later you will see others. We create folder, call it dummy, open it and paste the dummy file there. Why don't we just delete it? The good practice is not to delete anything. Try to keep all the data, try to keep the original data, and track all the operations, all the steps of processing. And a bit later I will show you how to keep your records systematically. It is very useful because of a high risk of errors and inconsistencies. And if you keep all the data there is no problem to go back and to reanalyze the data to see if there was an error or your results are good and correct. Now I just want to make sure that everyone is able to see this menu window.
Yes, we see.
Great. In this case, we move forward. The first and the biggest part of our class today is dedicated to spatial preprocessing with 6 steps. Reorientation, which is almost a manual procedure. It is not performed automatically by MATLAB, and I will explain you why it is good to help MATLAB a little bit at the very beginning of the analysis. Then realignment, here it is, coregistration, segmentation, normalization, and smoothing. The most complex and time-consuming step is segmentation. Typically it takes about 15-20 minutes per image. And at this point we will be able to make a break in our class and to let the MATLAB do their work. But first of all, we go to Check Reg button, which will allow us to make manual reorientation of your data. Why do we need spatial preprocessing in general? We do need it because the brains are very different, both between the subjects and often between the scans. The location of the brains in the scan differ from one experiment to the other, and even inside the same experiment the subject can move inside the scanner, which makes the position of the image is non-consistent. And if you don't want to get an artifact, you have to orient all the brains in the same way. But this is not enough. You can see that the shape of the brain is different from one subject to the other. So how then are you going to estimate the average statistical map of the activation in all your subjects? And how can you extrapolate your results to entire human population? It's a very hard task, and in order to do it, you will have to normalize all the individual samples to a standard canonical template, which is mostly done by segmentation and normalization. And the smoothing is the way to fight the noise in your data. In general, neuroimaging signal is very small and the noise is very high. and there will be few additional issues like multiple comparison problem, which requires very careful and thorough analysis and interpretation of your data. But we will discuss it in results section. Let me go to the data folder. As I told you, you create two folders where you will manipulate with your functional and structural data. You call them simply functional. And structural. You copy all the functional files. To folder functional. And you copy the single structural image to the folder structural. Very simple. Use the check range button in order to compare how the structural and functional scans look. And we will see how to approximately align them to canonical MNI template. Let's review again what is the functional and the structural images. The functionals look like this. The contrast is poor, and you cannot easily identify small anatomical structure, though you still can see the ventriculi, the gray matter, which looks more bright than the white matter, but the structural images look much better. You can discriminate gray and white matter easily, and the resolution is much higher. So let's try to run the check range in order to compare those two. You press check range. Go to the working folder, which is the data fMRI, and the mother of all experiments. You pick the functional file, just the first one, click on it, and you will see it below in the list of selected files. Go back, go to structural, pick the structurals. Structural, you see two files will be reviewed at the same time, and you press done. Here it is. You can see two files, and you see how well are they aligned. In fact, they are not aligned. If you click on the images, you can navigate them. Yes? Are there any questions?
Do you have any questions? Structural. You show structural and functional.